In the quadratic function above, here we have y equals a, quantity x plus 3, quantity times quantity x minus 1. A is non-zero constant. The graph of the equation in the xy plane is a parabola with vertex m, n. Which of the following is equal to n? So first, we can take note that this equation is a quadratic equation. This is a kind of a quadratic equation, and the graph of this quadratic equation is a parabola with vertex m and n. And we can remember that when we take the form of quadratic formula or quadratic equation in a parabolic form, we can say that y is equal to a times x minus h squared plus k. And from this quadratic form or quadratic equation in parabolic form, we can take h, we can take the vertex as the h and k. And so here we have this parabolic form of quadratic equation. Now the bottom line is that which of the following is equal to n? If we can take this equation, quadratic equation above, in this parabolic form of a quadratic equation, and find the value here, we have m and n, and this is actually represents h and k. And so when we solve it in this form of quadratic or parabolic form, we can take this number that is equal to n. Now we can transform this quadratic equation to this parabolic form, and let's do that. We have y is equal to a times x minus, is it x minus x plus 3 times x minus 1. Let's see. All right. So in order for us to transform this quadratic equation into this quadratic equation in parabolic form, let's multiply these two binomials here. And so we have a times this, the product of these two binomial. We can apply the FOIL method, and by applying the FOIL method, we'll have x squared plus this is negative x, and positive 3x will have positive 2x, so this is plus 2x, and we have here 3 times negative 1 is minus 3. So here we have a times the quantity of x squared plus 2x minus 3. We want to have a squared of binomial here, so we have to have a perfect square trinomial here in terms of 2x. And to do that, we're going to find the third term or the missing third term, and by completing the square. So we have a times x squared plus 2x, and we'll leave two terms here as a blank, and subtract 3 there, because this will be for completing the square. And we can remember that in completing the square, we take the numerical coefficient of the middle term, here we have 2, divided by 2, and squared it. And so we have 2 divided by 2 is 1, and 1 squared is 1. So we have here positive 1. And of course, we have to subtract the same number to retain the original value of this expression above. So we have positive 1 and negative 1, that will give us 0. And that will not change our original expression. We only do this because we want to complete this square. And so basically we have here x squared plus 2x plus 1 to complete this square, perfect square trinomial. And so let's simplify this. We can reduce this x squared plus 2x plus 1 to a perfect square binomial by having x plus 1 quantity squared. And again, we have a as a multiplier outside, so we can have there the groupings for the x plus 1 quantity squared, and we have here negative 1 and negative 3, and so we have there negative 4. And we have to put that inside that braces. And so that is equal to a times everything inside this braces there. And we can distribute that by, let's take that as y equals a times, okay, times a, rather times x plus 1 quantity squared minus 4 times a. And so here we have a parabolic form of quadratic equation, which is equal to a times x minus h squared plus k. Therefore here, this will be basically directly the value for k. So n is equal to k, which is equal to negative 4a. And that in our uh, choices falls under letter D. D is equal to negative 4a. That is equal to n. N is equal to negative 4a. And our answer is letter D.